All right, number 44, we're told to factor the expression completely, and we've been given 4x squared minus 11x plus 6. Now, as we've talked about in previous videos, when we are factoring, we always have to ask ourselves two questions. The first question is there a GCF? Because if there is a GCF, you have to factor it out. In this case, I don't think there's a GCF, so we can move on to question number 2, which is how many terms are there? If there are 2 terms, you're looking for the difference of perfect squares. If there are 3 terms, like we have here in number 44, we're going to use the scissors method, or if you learn the AC method or trial and error method, you're going to use one of those methods. If you're one of my students, you've learned the scissors method. And of course, if there are 4 terms, which we've already looked at previously, you will factor by grouping. So the scissors method tells us that we have to look at the coefficient of our x squared term, and we're going to look at the constant. So 6. And you know what? I'm going to change colors here to blue. All right, there we go. So we have 4 and 6. We're going to take the 4, we're going to take that constant of 6, and we're going to put it into a little t-table. And we're going to list all of the factors of each of these respective numbers. So the factors of 4, well, 1 times 4 gives us 4, and 2 times 2 gives us 4. And 6, we have, well, 1 times 6 and 2 times 3. Now what we're going to do is try to combine these different factors in a way that will add to give us a negative 11. And as I've mentioned in class, we always want to try to start with the numbers that are closest together. 9 times out of 10, the numbers that are closest together, these factors will work for us. So let's go ahead and stack our 2 and 2 vertically, and then we'll stack our 2 and 3 vertically. And normally we would flip this second set of factors, meaning we would write 3 and 2, but notice in this case, because the factors of 4 that we're using are 2 and 2, even if we were to flip this second set of factors, we would still end up with the same combination. And so all we're going to do is we'll try these combinations here. So 2 times 3 gives us 6. 2 times 2 gives us 4. Is there some combination of signs that we can use a 4 and a 6 to get to a negative 11? No, I don't think so. And so in this case, we can say, all right, well, this can't be our combination. So let's go ahead and try, how about 1 and 6? Well, we could try a 6 and a 1. 2 times 6 gives us 12. 2 times 1 gives us 2. Again, can we use a 12 and a 2 to get to a negative 11? No, I don't think so. We could. Again, if these were not the same number, we would flip the 1 and the 6 and try a different combination. But in this case, that doesn't work. So let's go ahead and try, instead of 2 and 2, let's go ahead and try 1 and 4. And again, we'll still try the 2 and the 3 together. So let's see, 2 and 3. Well, 1 times 3 gives us 3. 4 times 2 gives us 8. Is there some combination using an 8 and a 3 that we can get to a negative 11? Yeah, I think we can. And remember, we're adding. And so if we're adding, trying to get to a negative 11, if we make both the 8 and the 3 negative rather, we can get to a negative 11. And remember, whatever sign you put with this cross product simply bounces over. Whatever sign you put with the cross product simply bounces over. And then we're going to wrap horizontally our factors. And we were using an x, so we'll pop in an x after the first term here. And so what we end up with is 1x minus 2. But we're going to get out of the habit of writing the 1. So we'll have x minus 2. And our second factor, 4x minus 3. So 4x minus 3. And there we have it, number 44.